interesting feature of insect learning is that, in addition to reward-based learning, insects need no prior reward to learn particular aspects of their surroundings. Thus, bees perform special flights when they first leave their nest, during which they learn views of the nest surroundings that will later help them to get home. The longer a learning flight is, the greater the precision in locating the nest. A bumblebee visits many different flowers. On encountering one, she decides whether the flower is worth exploiting. If so, she learns the flower's appearance and location, performing a similar flight on leaving the flower.
Unlike learning flights from nests, flights on leaving flowers are influenced by the reward that to be extracted from the flower. Just as you might remember the name and location of a good restaurant, but forget a bad one. We wanted to know exactly how the flights change with the flower's reward level. To find out, we experimented with bumblebees that experienced a flower for the very first time. Sadly for us, the experiments took place in a greenhouse, not in a beautiful sunny meadow.
Bees were tested one at a time. Each bee found a different concentration of sucrose in the center of an artificial flower. This bee, here in the picture, has just finished feeding and is at the start of the learning flight, looking back at the flower.
To show more clearly what's happening, we pick out when a bee looks at the flower, which we show in yellow. This bee starts pivoting around the flower at a close distance. As she moves away, she repeatedly turns back to look at the flower, often flying towards it while facing it.
When we varied the concentration of the sucrose, bees that had drunk 50% sucrose spent more time facing the flower than bees that drank 20% sucrose. This trend became clearer when we took notice of the sizes of the bees.
Foragers vary in size over almost a twofold range. Size is most often assessed by the width of the thorax. It is an easy measurement to make, and width correlates well with other measures. The dots show how long a small bee and a large bee face the flower during its learning flight. While small bees did a little more flower facing than big bees after drinking 20% sucrose, the relation reverses after drinking 50% sucrose. The large bees then did more flower facing than the smaller ones. This result tells us that big bees are fussier than smaller bees about what they regard as a good flower and invest in learning accordingly.
Our findings match nicely previous experiments and observation about small and large bees when they forage in the wild. Large bees fly faster and further and forage more efficiently. They can thus afford to explore and wait until they encounter good foraging spots. Small bees have a more restricted flight range and make do with what they can encounter when they are closer to the nest. This cartoon captures our overall conclusion. Each forager helps feed the colony. Large or small, you can still make a contribution so long as you know your size.